Okay, guys, welcome to the Security Dev Room talk about application whitelisting in Linux environment by Radovan Sroka.
Hello, FOSDEM. My name is Radovan Sroka, and I'm working as a software engineer in Red Hat in Brno. And I'm very excited to be here and as a speaker and as a developer. So let's talk about application whitelisting. What is an application whitelisting? Well, it is a security practice where the application or the software itself is able to run according to its presence on the list. And usually administrator is responsible for maintaining such a list. So it's his choice what will be on this list. Why is that so important? Well, it adds another level of security to the system, and application whitelisting capability is a part of the many certification schemes such as common criteria and many others. This basically pushes software vendors to implement some sort of application whitelisting solution. So where is Red Hat? Well, we introduced Fapolicyd framework in RHEL 8.1 and Fedora 29, and it's available to use for everyone. Fapolicyd framework is a very simple and lightweight solution, and it benefits from RPM and DNF integration. It has also audit support, and it is built upon Fanotify API. Fanotify API is a kernel API, which is very similar to iNotify. Who knows, iNotify can watch file system events based on system calls like open, read, write, and close. But Fanotify can also watch exec system calls. And moreover, it's blockable on system call side. That means that system call will be paused until decision has been made on the other side. So this is very simple scenario how Fanotify can work. So we have two processes here. The first on the left is bash, which is being watched, and it would like to run ps command, standard Linux utility, and this system call is will be on hold. Execution of this system call will be on hold, and kernel will notify the daemon, which is the watcher in this case, Fapolicyd daemon, and it sends an event to this daemon, and daemon can see that something is happening on the system, and we can see from the event that bash is going to execute ps command with such as ID. And this daemon has to decide what to do with it. Well, it can send allowed, decision allowed. That means that exec.ve will eventually success. On the other side, it can send denied, and that means that exec.ve will fail, and bash will be not able to exec ps command. This is how Fapolicyd framework architecture looks like. Well, it has multiple backends, and the most significant part of the project is the daemon itself. When the daemon starts, it loads all data from backends, and it saves them into database, and then it can create some query to verify trust, let's say. So how can we configure it? Fapolicyd can be configured in 3 ways. The first one is rules file. We can find there the default set of rules, set from distribution. The second way is configuration file for the daemon. You can tweak some performance options there, usually. And the last way how to set it is Fapolicyd trust file. And there we can put a list of applications we trust, actually. So, as I said before, there are multiple optional backends. Right now, there are two possibilities implemented. The first one is RPMDB, which is the backend which loads all data from RPM database. And the second one is Fapolicyd trust file, which, as I said, contains the list of trusted applications. And when the application is trusted with a default set of rules, it will be allowed. So Fapolicyd has its own rule language implemented, and it has subject-object notation, very similar to SE Linux or audit. And it can be divided into 4 parts, where the first is the decision. Decision is the action what will be taken when rule matches. And it can be allow or deny. We can combine it with audit, so it also the decision will be audited. And we can find the decision in audit logs. The second part of the rule is permission. Permission can be open or execute. That comes from Fanotify API, because there are two types of events there, and it is based on system calls. And there is also any keyboard that can match any of them. The third part of the rule is subject. It's started before colon, and it is a process that is running, and it wants to call exec or open system call, and the object, the part of after the colon, is usually file that is going to be executed or opened. We can install a Fapolicyd framework very easily on Fedora or RHEL. Just it's as simple as that. So let's try to run it. When we want to, let's imagine that we have some applications in home dir, and we would like to run them even if they are not installed from RPM. So, for example, I have in my bin 2 applications. First is my binary, which is a normal, usual compiled binary. It is actually copy from ls command. And the second is some Python script. So if we run this binary, it works. So let's start the daemon. When we run it in debug mode, as a root, of course, and we save the output, we can try to run it again, and it is not possible. Because this particular application is not trusted. So what can we do about it? Well, we can investigate the output of the Fapolicyd. If we start looking for my bin, we should find something like that, which says that rule 9 from rules file has matched. It is some default rule that denies everything, let's say, and it denied this event, which had type execute and some metadata, and we can see that the subject is shell. It is ZSH, and the object is my binary. So my shell would like to execute my binary with this file type as an executable. So let's try to construct a rule from that. So we want to allow this event that has permission execute with this subject, which is shell, and we would like to force that shell has to be trusted. Okay, that means it has to be installed from the standard repository, let's say. And there is my binary, which is in the path, and it has this file type, and we know that it is not trusted, but this is optional. It doesn't have to be there. So if we put this rule at the beginning of the rule file, then we can try to run our binary again, and we can see that it works. What about the Python script? Well, we are able to run it right now with Fapolicyd disabled. So it's some whole world script. If we run again the Daemon as before, we can see that it is not possible to run it, this Python script. So we will investigate again with the same approach. We will grab for my app, and we can see that there was an event that says, actually, it is a very similar event as before. It has the same subject, the shell, and but the object is different. Now it's my app, and it has different file type, which is application Python right now, or text Python. So if we construct the rule, it is also very similar rule as before. We can set trust 1 for subject, and we should be able to run this Python application from ZSH as we were able to before. But we are not able to. So let's start the second round of investigation. Well, if we grab again in the output of Fapolicyd, we will grab 2 lines now. The first is allowed, permission execute. So the rule we put at the beginning of the rules file, it actually matched. But there is second event that says it needs to open this file actually from shell. So it looks like shell is first or part of the execution, or exec system call is also called open system call, right? So this is the reason why is that so. So if we can see that these 2 lines are very similar, we can use any keyword for permission, and we can allow these 2 events with 1 rule. If we again update our rules file and run the Python script, now we can see that we are able to. What's the difference between these two ways of running Python scripts? So on the left side, you can see that shell is opening this Python script, but on the right side, it looks like Python 3 interpreter. Python 3 interpreter is running the script, right? So if we grab for my app again, we can see that subject is different. But we can fix this with all keyword instead of exe. So we have a rule that will allow any permission and with any or all subjects that are trusted. And again, the object is the same as before. The second way how to enable this application is to enable a whole directory. But this is not very secure, right? And the third way is the best from my point of view, is to add these applications to the Fapolicyd trust file, as we can see on the image. And we are able to run them. So if we are okay with our configuration, we can just simply enable Fapolicyd with systemd. That's all. Thanks. Any question?
How do you prevent race conditions in the policy handling system? As in, especially during boot, it might take some time before the daemon that you use in order to set up the policy is available.
It depends how you. Depends how the unit file is written. So you can start this daemon very early, or even in the early boot.
Right, so I've got two questions. Hopefully one of them will be pretty short. So are you aware of any efforts of actually getting Fapolicyd employed in other distributions other than Red Hat based? I mean, it seems that apart from RPMDB integration, it should be, there's nothing in there that should not work under other distros.
Well, I made a page last week that made libRPM optional, and there is an API that can be easily extended to some other trust source. So now it is not possible. You can use it just only with this trust file, but you have to maintain it. But it's not easy. But you can implement some other source of the trust very easily. There are, I think, 3 functions you have to implement in C.
Okay, second question, if I understand correctly right now, this is very much limited to identifying files to allow or deny by their location, which obviously means that if you have got permissions to copy execute files from some directory that you give them the home directory, all the user has to do is just copy the file to a different place. So I suspect it might be a limitation of the Fanotify API, but are there any plans to actually extend this to some sort of I don't know, integrity-based integrity-based or hash-based policies?
Let me think. So, yes, we are not checking the integrity. We have all the hashes. We can do that. We have hashes from RPM database. So theoretically, it can work. It can be implemented with a few lines of code. But we are not doing that right now because it has some performance impact right now, and we would like to put it down. So, but if you want some real solution for that will compute all hashes and all files, so there is an IMA, but that has big overhead, really.
So the adding the trust just confirms that the package is installed and that's it? That's the only check that's happening? Adding trust, adding trust 1, all that does is check if the package is installed and it's running from that location? It doesn't do any SHA-based checks, nothing else?
I just said that.
That's what I'm,
Yeah.
just clarify, okay.
Any other question?
Which system calls are you preventing? Are you also preventing like popen, stuff like that?
We are looking for like whole family of system calls, right? So all exec system calls or all open system calls. Like they are watched by this API.
So any other questions?
Have you considered on implementing this with SE Linux or AppArmor's style of settings instead of doing it anew? What I want to say is, would it be possible to do exactly this with SE Linux in a special setting? Like you do not have to disallow everything with SE Linux, just like a small portion and then allow stuff again? Or was it asked already because he's laughing?
Because it's a like common question. Well, some limited scope can be implemented via SE Linux, but there is a problem with these labels because you have to check them like all the time, and you have to rely that these labels are okay. So you would technically would need to loop restore.com or something like that, like all the time. So we would like to enhance this application whitelisting to really check hashes and content of the file, and this is not possible with SE Linux because SE Linux has the label and but it doesn't really care about the content of the file or hash or something.
So one last question. Anyone? So if no, thank you for your presentation.